This video is presented by Volcano.
The vast Pacific Ocean often holds its secrets deep within its blue expanse. But on the first day of June in the year 2025, a dramatic secret burst forth with astonishing ferocity. Near the beautiful kingdom of Tonga, an archipelago of islands known for its serene waters, the ocean surface began to churn and boil in a most unnatural way. An underwater volcano, a colossal giant long slumbering in the dark abyss, awakened with truly immense and terrifying power. This was no gentle stirring of the sea giant bed. It was, instead, a raw and untamed display of Earth's fiery, molten heart, a reminder of the planet's dynamic nature. The world was about to witness something truly spectacular and profoundly humbling. The very ocean itself seemed to part, revealing the formidable geological forces at play beneath. The initial visual impact of this colossal event was nothing short of breathtaking. Mighty plumes of superheated steam, dense grey ash, and fragmented volcanic material surged upwards from the ocean's depth. They climbed high into the atmosphere, creating a stark and dramatic column against the clear Pacific sky. This was a display of Earth's incredible power, a natural spectacle of both creation and destruction, unfolding before our very eyes. The colors were a stark palette of dark greys, browns, and brilliant white steam, all illuminated by the sheer energy of the eruption. The textures of the plume were constantly shifting, from dense billowing clouds to finer, hazier dispersals, painting a dynamic portrait of geological upheaval far from human shores. The thought of an underwater volcano erupting carries a particular kind of awe and perhaps a touch of unease. These are mountains hidden beneath the waves, their fiery summits concealed by kilometers of water, their immense power largely unseen, unheard. The Pacific Ocean, in particular, is a region of intense geological activity. It is famously rimmed by the Ring of Fire, a vast zone where tectonic plates collide and interact, giving rise to frequent earthquakes and volcanic eruptions. Tonga itself sits upon this active margin, making such events a possibility, though one of rarely witnessed scale and intensity. This eruption serves as a potent reminder of the immense energies constantly shaping our planet, often hidden from our daily lives. The immediate vicinity of the eruption would have been a scene of extraordinary natural chaos. The normally placid waters would have transformed into a turbulent, seething cauldron. Great waves would have radiated outwards from the epicenter of the blast. The air, even at a distance, might have carried the distinct acrid smell of sulfur, a telltale sign of volcanic activity. Imagine the sounds, the deep rumbles from beneath the waves, the explosive crackle as superheated rock met cold seawater, and the roar of the escaping steam and gas. The sheer raw energy released during these first moments is almost impossible to comprehend fully, a testament to the powerful forces that govern our world. The world learned of this astonishing event with remarkable speed, largely thanks to the ever-watchful eyes of technology. Stunning satellite footage and breathtaking drone-captured visuals of the eruption quickly spread across social media platforms, going viral within hours. This is the modern age of observation, where events in even the most remote corners of our planet can be captured and shared globally almost instantaneously. It allowed millions, if not billions of people to become immediate witnesses to this raw display of nature's power. This rapid dissemination of information also alerted scientists and authorities, enabling a swift response to understand and monitor the unfolding situation near Tonga. Satellite imagery provided the first grand overview of the eruption's sheer scale. From their vantage point high above the Earth, these orbiting sentinels captured the initial moments of the powerful column bursting forth from beneath the ocean's surface. The images showed this dark, mushrooming cloud rapidly expanding, creating a vast plume that stretched for many kilometers. This perspective from space is invaluable. It allows us to grasp the immense area affected and the sheer volume of material ejected into the atmosphere. Scientists can use this data to measure the plume's height, its rate of expansion, and its direction of travel, all crucial pieces of information for understanding the eruption's magnitude and potential reach. Closer to the action, unmanned aerial vehicles or drones offered a more intimate and visceral perspective. Drone footage, likely captured by brave researchers or automated systems programmed for such eventualities, showed the turbulent seas in dramatic detail. The water's surface was seen literally boiling in places, a direct consequence of the intense heat emanating from below. Fragments of pumice, a lightweight volcanic rock filled with gas bubbles, could be seen floating on the agitated waves freshly created by the eruption. These close-up views reveal the sheer violence at the interface, where molten rock meets cold seawater, a chaotic and dangerous environment, yet utterly fascinating to observe from a safe distance. Having these two distinct technological perspectives, the broad view from satellites and the detailed close-ups from drones, is incredibly beneficial. They offer complementary information, painting a far more complete picture of the event than either could alone. Satellites provide the crucial context of scale and atmospheric dispersal essential for understanding the wider impact. Drones, on the other hand, give us ground truth details, showing the physical processes occurring at the eruption site itself. This combination of advanced imaging technologies has provided an unprecedentedly clear and comprehensive record of this underwater volcanic event, offering a rich data set for scientists to study for years to come. Underwater volcanic eruptions, such as this dramatic event near Tonga, are considered relatively rare occurrences, or at least rarely observed in such detail. They are also events of profound scientific significance. The vast majority of Earth's volcanic activity actually happens beneath the oceans, hidden from our direct view along the mid-ocean ridges and at submarine volcanoes. However, these deep-sea eruptions are incredibly difficult to study directly, due to the immense pressures and the opaque nature of seawater. Therefore, when an eruption like Tonga's occurs in shallower waters and is so well documented, it provides a precious and invaluable opportunity for scientific investigation, a natural laboratory opening its doors. These spectacular events offer us unique insights into the inner workings of our planet. They are a direct manifestation of the powerful forces of plate tectonics, the slow, relentless movement of the Earth's crustal plates. By studying the lava, ash, and gases released, scientists can learn much about the composition of the magma deep within the Earth's mantle. They can investigate the specific processes that lead to such explosive interactions when magma meets water. Each eruption can add a new piece to the complex puzzle of how our planet functions, how it releases its internal heat, and how new crust is formed on the ocean floor, shaping the very surface of our world. Furthermore, underwater volcanic eruptions play a crucial role in shaping the ocean floor and influencing marine life over geological timescales. These eruptions build new seamounts, which are underwater mountains that can eventually rise to become islands. They also create unique environments, such as hydrothermal vents, where hot, mineral-rich fluids gush from the seabed, supporting extraordinary ecosystems, teeming with specialized life forms that thrive in complete darkness, independent of sunlight. While an eruption can be locally destructive to existing marine habitats, it is also a powerful force of creation, laying the groundwork for new life to colonize and flourish in the aftermath. The chemistry and physics involved in an underwater eruption are also fascinatingly different from those on land. The immense pressure of the overlying water column can significantly influence how an eruption proceeds, sometimes suppressing explosivity, or at other times, if water rapidly turns to steam, enhancing it. The rapid cooling of lava as it contacts cold seawater leads to the formation of unique volcanic rocks and structures, such as pillow lavas, which are rounded pillow-like formations, and vast fields of lightweight pumice, like those observed floating after the Tonga event. Studying these products helps us understand the specific conditions under which they formed, revealing more about the submarine volcanic environment. The scientific community responded with great urgency to the news of the Tongan eruption. Researchers from around the globe are now undoubtedly mobilizing their efforts to study this significant event in as much detail as possible. This involves deploying various monitoring instruments, potentially including research vessels equipped with sonar to map the changed seabed, and remotely operated vehicles or ROVs to collect samples of newly formed rock and water. The primary goal is to gather comprehensive data while the site is still fresh and the immediate after-effects are observable. This period immediately following an eruption is critical for capturing transient phenomena and understanding the eruption's full impact. Scientists will be particularly keen to learn what makes this specific eruption near Tonga noteworthy. They will analyze its magnitude, the depth from which it originated, and the composition of the ejected materials. Comparing these details with data from previous underwater eruptions, such as the 2022 Hunga Tonga Hunga Ha'apai event, will provide valuable context and highlight any unique characteristics. There is always the potential for new discoveries, perhaps revealing unexpected geological processes or shedding light on the specific triggers for such powerful submarine events. Each eruption has its own signature, and deciphering this one will contribute significantly to volcanology. Beyond the immediate geological interest, this eruption has broader implications for our understanding of oceanic effects. Large underwater eruptions can inject significant amounts of volcanic gases, minerals, and heat into the water column, potentially altering local water chemistry and temperature. This, in turn, can affect marine ecosystems in the surrounding area, sometimes positively by providing nutrients, but also negatively through acidification or turbidity. While a single eruption like this is unlikely to have a major global climate effect unless it is exceptionally large and gas-rich, understanding its contribution to ocean chemistry and atmospheric composition is still an important area of ongoing research. Furthermore, such events always raise awareness of tsunami risks associated with submarine volcanism. The future of studying such phenomena lies in continued observation and technological advancement. Events like the Tongan eruption underscore the importance of improving our ability to predict future volcanic activity, both on land and beneath the sea. This involves enhancing our global networks of seismic and GPS monitoring, developing better models of magma movement, and refining early warning systems to protect coastal communities. The Earth's geology remains a source of enduring mystery and immense power. This recent event serves as a vivid reminder of that, and it will undoubtedly spur exciting new avenues of research, furthering our comprehension of the dynamic planet we call home.
This video is presented by
If you like the video, please subscribe.